Okay, I think, well, we have some free seats. Perhaps some people will come in afterwards. Well, our next talk is held by Colin. He will tell us something about databases and how and why and when they will crash. Have fun.
Hello, hi, good evening. I'm between you and beer, and lots of beer, so I'll try to keep this brief. Keep in mind you have a bus leaving here at, I think, quarter to 7, so get ready. You all going to be at the party? Yes, okay. So I'm going to talk to you about some lessons from database failures, and should I ask who doesn't use a database here? You don't use a database, okay. At all? Like never use MySQL or Postgres or? Okay, you have. You try to. Okay, yeah, fair enough. I myself have been working on databases for about 15 years. So I say database a lot. I work at Percona now, where we not only make servers for MySQL, but also for MongoDB. And everything we do is 100% open source. Before that, I was on the founding team of MariaDB Server. I quit last year because they were making some software that wasn't open source. And done a bunch of other things in the open source world. So my agenda for today is quite simple. I'm going to talk to you about backups and verification or validation of backups. Because having a backup is that you've never tested is quite useless. And this applies across the board, I guess, not just for databases, right? You should be able to restore any kind of backup, realistically. I'm also going to talk to you about replication and failover. And naturally, a lot of what I talk about will be leaning towards MySQL, mainly because it's used everywhere. It's the one that's failed a lot in public as well, and it makes sense for me to talk about how you can work around it. And I'll also talk about security as well as encryption, which is new to the MySQL world. It's not something that's been around before. I won't talk about something like NDB cluster. Has anybody here used MySQL NDB cluster before? Or MySQL cluster? No? Okay, yeah. Okay, so that's not the focus of this particular talk because NDB cluster actually doesn't fail. Yeah, so you're thinking I might be pulling your leg here, but this is actually true. It's typically used in the telco space, and it manages to keep call data records alive for most telcos, actually. It's where you keep home location record information, so when you move cell from cell to cell and some cells triangulate, it keeps you alive in memory. It's a mostly in-memory database, though now you can have on-disk storage as well, but you still have to keep the indexes in memory. And it's a highly available shared nothing architecture where the minimum setup involves having 5 nodes as opposed to just having like maybe 1 or 3 nodes. So yeah, I'm not going to talk to you about NDB cluster. And if you don't believe me about NDB cluster and its infallible nature, most likely your cell phone, I mean, I'm going to guess most of you have a cell phone here. Most likely your cell phone provider has actually paid someone, equipment manufacturer, to actually ensure that there is something like NDB running in the back end. So it more or less works for telcos. And it also works for the US Navy, actually. So they do this, they have missile launches from these ships, and you never want a split brain scenario. Yeah, this may be funny, but this is real. But the caveat is they run it on an EAL4 based operating system, which is actually Microsoft Windows. Well, there are case studies on the internet. You can go read them. So yeah, I'm not going to talk to you about NDB cluster. Besides that little pitch. Also, what this talk is going to be focusing a lot about is learning from incident reports. And I guess a lot of you spend time reading other people's incident reports and also writing them if you happen to have failures. I'm going to include the standard disclaimer here, which is nowadays affectionately referred to as hugops. I'm taking examples from blameless postmortems here, so I'm not blaming and shaming anybody. We're just looking at facts of the situation. And in fact, later on, you'll see that there's a company that actually made use of Percona software, and they actually failed because of some Percona software. But then, because we fixed some bugs after that as well, so it's a huge bonus. And I think we all generally share common values because we don't want to repeat failure, and I think together we can improve. So, does anybody remember this website called Magnolia? No. Well, the internet obviously remembers thanks to the Wayback Machine. This website started around 2006. They were focused on open standards, microformats. They were a bookmarking service. There was also a paid component to Magnolia, though they claimed they never made any profits. And shortly after Magnolia, you may have heard of this service called Delicious, which Yahoo bought, and possibly that was not good for them, and then they may have sold it back out again. And now you can also pay for a bookmarking service called Pinboard, pinboard.in. So maybe you're familiar with some form of bookmarking service, as opposed to just saving everything in bookmark.htm. So Magnolia had a very interesting failure. They ran for about 3 years, and then they realized at the end of January they had a complete outage. It took them 3 weeks for them to confirm that their user database was corrupted, and basically they were essentially dead. And what actually happened was they had a fairly simple Ruby on Rails application hosted on Mac Minis, so not entirely uncommon thing to do back in 2006 or 2009. They had Xserves. I mean, you can't buy them anymore, but they were of data center quality. And they had about a 500 gigabyte MySQL database. So if you just think about it, all they did was store links, and that took up 500 gigs of data. So you can think that they actually stored quite a lot of data in their user database. They encountered file system corruption, and HFS Plus is a wonderful file system, but it's not really data center ready, I would say. Most people running a MySQL database today will run it on XFS or ext4. They will not be running it on HFS Plus. And not only did they have a file system corruption, they also ended up having a corrupted database backup. And the reason was quite simple, was because they never checked if their backups could ever restore, and they thought that they would make rsync backups over the FireWire network, and this would be good enough for general purpose restores. Now, it is most likely they were using MyISAM as a storage engine. They don't say, and we can't find out any information. And rsync is totally not a good way to back up MySQL data, because it's great for maybe static data, but not constantly changing data. So this is definitely not a way to back up MySQL. They confirmed that their service more or less was dead later that year in late 2009. But it took them over nearly a year to go from corruption to saying, sorry, we've lost all your bookmarks. Now you think to yourself, bookmarks may be not that important, but some people are actually attached to their bookmarks or any of their content. So I think one of the major things here is you never want to lose data overall. I mean, losing data is bad. So how would you do Magnolia today? For one, you may use something like EC2. You may not actually go out there and buy a server. You may use EBS snapshots. You may make use of an RDS database, so you don't have to have a database administrator, so that Amazon does all the heavy lifting. You may also want to have a multi-availability zone deployment. But we are at the open source data center conference, aren't we? So I'm gonna presume that many of you like self-hosting. Yes? Okay. So we'll go with the self-hosting option. And keep in mind, you can do the whole self-hosting option in some kind of cloud image as well. For one, you will make backups with a tool like Percona Extra Backup. Extra Backup is more or less the default way to make backups today for MySQL. If you're going to make logical backups, you will use MySQL dump, but for any other form of backup, you will definitely want to use extra backup. Extra backup works for InnoDB as well as MyISAM, though we don't recommend you to use MyISAM any longer. Extra backup works across the board as well, so it works for MySQL, Percona server, as well as MariaDB server. Now, another thing you'd probably want to do is you'll probably want to occasionally spin up a slave instance. And when you want to spin up a slave instance, you don't have to do flush tables with read lock anymore in MySQL 5.7, as well as MariaDB 5.5 and greater, and Percona Server 5.6 and greater. That's because you can do start transaction with consistent snapshot, and then you will do a MySQL dump with single transaction and master data to take a backup, a consistent snapshot of whatever was executed before you ran start transaction with consistent snapshot. Your database can continue getting transactions committed to it, and this will have a hook that'll ensure that it works continuously. You'd never ever have to do flush tables with read lock any longer. Now that we're talking about MySQL versions, I'm curious to know as well, how many here use MySQL 5.7? 5.6? When I say MySQL, I can mean Percona server as well. 5.5? Wow. Okay, anything older? Who uses MariaDB 10.1? Okay, 10.0? 5.5? Okay. So I'll try to talk about differences as we go along as well. Another thing most people do nowadays in production is they don't back up their master data either. They back up from a replica, a slave basically. You never back up, you never want to add more load to your master. Another very cool thing that's available is this thing called replication event checksums. Now, replication event checksums came to the MySQL world in MySQL 5.6, and in the MariaDB world in 5.3, which was backported from 5.6. And basically what you get is a checksum written to both the relay as well as the binary log at various points. And if there's an error caused by, say, memory or disk or network failures, it'll actually stop replication. So MySQL replication is super easy to set up, right? But if you don't monitor it, it may actually give you corrupted replicas. And this is one of the major problems with, say, statement-based replication, which is why nowadays you have things like row-based replication. And of course, you can implement checksums, which is even better than just using row-based replication. And of course, it can be implemented on a per-slave basis as well. So you can actually get the most flexibility for when it is deployed. And the key point here is that if there is a mismatch, it will stop. And you as an operator will get to know that that was something went wrong, and you get to fix it. As opposed to just taking on failed data in your replicas and then finding out when it's too late. Does anybody remember this website called Couchsurfing? Or does anybody use it? Okay. Some of you do use Couchsurfing, so yes, it's still very much alive. So Couchsurfing, in 2006, did not have the concept of an incident report, but they did write a blog post. And they said that they had a major avoidable hard drive crash, and then the incremental backups weren't executed in the correct manner, and 12 of our most important data files didn't survive. Ooh. So Couchsurfing's major problems. Hard drive crash, that's something you totally avoid now today, largely because you don't only have one machine. And you will always execute incremental backups in a correct fashion. And if you made a mistake because a developer made an error, there are ways to ensure that a replica does not have the error that said developer has executed. Now, Couchsurfing is still more or less around, thankfully because Airbnb did not exist in 2006. If Airbnb did exist, Couchsurfing would be completely dead now, probably. Now, it was actually caused by developer error. And one of the cool things that one could actually have avoided this problem was if they had actually had the ability to have a time-delayed replica. Does anybody here use a time-delayed replica? or time-delayed replication in production? Okay. So MySQL 5.6 was the first to introduce time-delayed replication. And basically, you can have a replica that is 5 minutes delayed, 2 hours delayed. And no matter what you do, you can always point the replica being delayed can always go back and be a master if need be. You don't have to reload data, so to speak. It is implemented at a per slave level as well, so it holds the SQL thread, and replication delay can be set for a slave user to apply replication events immediately, or another one to apply it over a certain delay of time. Now, basically, if you have a deployment error, this is a great way to work around it. But this would not have saved Couchsurfing because the feature didn't exist back then. There was an open bug reported in 2006. It took a while before there was a work log. A work log is a way to get features into MySQL gets published. And then the feature got pushed many years later, and only in a much later generally available release in February 2013 in MySQL 5.6 could you get time-delayed replication. And this, from what I gather, is something that many people, even people in the next room at Booking, tend to like to run, because when a developer makes an incorrect push, everybody does things in a live fashion nowadays. It's easy to roll back. Question? Right, so the question is, how would you work around the fact that this is a surefire way to guarantee like the last 30 minutes of data being lost when you roll back to, say, a database that's 30 minutes delayed? And the answer is quite simple, actually. Nowadays, you have this feature called global transaction IDs. And even though that last 30 minutes of data may be lost, you can very quickly replicate the data that's missing from a known master, or a known slave, actually. And this partially can happen either via tools like MySQL high availability, or it can happen via just executing commands and saying you'd like to copy data from this bin log position, this global transaction ID position, minus this one. So it's like this GTID position minus one. So this actually works relatively well in terms of catching up. So your application tier will not be able to see what may have changed in the last 30 minutes, but it'll catch up fairly quickly. So you may have out of band data for that time frame only, but it'll be much less painful than having to, say, do an online schema change because the developer made a schema change, and you found out 30 minutes later that was the wrong schema change to push, and you need to actually come back to the old schema. Does that sort of answer your question? Okay. Oh, and since there are at least a couple of MariaDB users here in the room as well, it is worth noting that time-delayed replication, while a feature of MySQL since 5.6, and global transaction IDs as well, a feature since 5.6, time-delayed replication does not exist in MariaDB server yet. It will come in 10.2, but 10.2 is not GA. So if you're using MariaDB up to 10.1, this is a feature is still not available to you. So why do people replicate? Most people replicate because they want to scale out. You want to have several masters and have several slaves that read off each and every master. Then you can have multiple tiers of masters and slaves. Sometimes you want to have failover. I mean, this has become a very common request. People want failover or out-of-the-box failover. And they want master failover. So when the master goes away, they'd expect that one of the slaves, the most current slave, will become the new master. And then the other slaves will now replicate off the new master. And naturally, because we like automation in things, many people want automatic master failover, not just regular failover. A lot of people also want geographical redundancy across data centers. So very common issue is that today, I guess Berlin is a fairly safe location, but if you had a data center in Manhattan, occasionally the banks of the river burst and you end up flooding the data center. So that happened a couple of years ago if you had a data center in New York. And from a more personal standpoint, I don't know how many of you go to South Korea, but I go there maybe every couple months, and I like to use an American Express. But then one day I couldn't swipe my card, and that was not because it got on a limit or anything. It was because the data center that handled American Express transactions was a Samsung data center in Ilsan. It caught fire. So for a whole week, you could not swipe your Amex in South Korea. And if you happen to use a Samsung phone, at least for a couple of days, your S-Chat, I'm guessing nobody uses S-Chat anyway because it sort of is dead now, your S-Chat would stop working. And if you had a Samsung Smart TV, your TV on a Sunday night in America was pretty dumb because it could not connect to the data center. All the Smart TV options were gone. So that's an example of needing to have redundancy in your data centers because maybe they catch fire, they get flooded, and in today's political climate, maybe they get bombed. Who knows? Anyway, the other reason why you do replication is because you want to make online schema changes. Now, if you use something like MySQL 5.6, the ability to use tools like GitHub's Ghost, Percona PT Online Schema Change, or Oak Online Alter is something that you can totally do today. So you can actually make changes to your schema in an online fashion. And MySQL 5.7 improves this even further by allowing you to resize varchars. So online DDL is one of those things that can cause replication lag naturally. And many tools use triggers to make these online schema changes work, with the exception of GitHub's Ghost. So if you're looking for this tool, it's GH-OST, GitHub's online schema tool. And they, at GitHub today, run a magnitude of online schema changes on a daily basis, and it still keeps GitHub going without you ever noticing they made a schema change. Now, lots of people do online schema changes in production. So if you want to go and read up on this, you can go look at the UK Government Digital Service and Wikipedia, Basecamp's 37 Signals. Huge chunks of people talk about how they like to do online schema changes. So I highly recommend you to take a look at all those blog posts, basically. And of course, the first people that pushed online schema change to become something that the public would like to do more was Facebook. Facebook released the online OCS tool, the online change schema tool, based on Oak Online Alter, and they were the ones that started pushing things forward. And Facebook's tool is also open source, though like most things that come out of Facebook, it's open source, it may be good, but it's not supported by Facebook, so you'll have to get support by yourself or some third party. So let's talk a little bit about replication. The default replication in MySQL is asynchronous. It's extremely fast, and it just works. That means the master gets a transaction. It may not have transmitted it to the slave, but it gives the client an OK. This can happen in typically 20, 30 milliseconds. This is why replication is easy to set up and is super fast. However, if you want to do automated failovers, it is very clear you'll need something like a semi-synchronous plugin available. And you'd want the lossless semi-synchronous plugin because you don't want to have phantom reads where the data may get lost because of the way it commits to the engine, but then an application tier may have seen it. Now, the enhanced semi-sync plugin is available in MySQL 5.7 and greater, so this is something that I highly recommend you to take a look at using. What this means is that you have a master that gets a transaction, and this master must commit the transaction, must ship the logs to at least one slave before it sends an OK packet back to the client. So you will never ever be in a situation where you've lost a transaction. Now, you couple semi-synchronous replication with an automated failover framework, and you have the ability to provide typically less than 30 seconds automated master failover. And that could be your SLA, because this is what people are running in production at very, very large companies nowadays. There is also synchronous replication, which I talked about, NDB cluster earlier, but there's also Galera cluster, as well as the competing implementation called MySQL group replication. Synchronous replication suggests that all nodes are now equal. That means, in the case of Galera, you get a transaction that is committed to, say, node 1, and when it's time to write it to the storage engine, using optimistic concurrency control, that node will now write to node 2 and node 3, and if there is a problem, say, with a hot row, then there is a rollback. It's sent back to the client as a rollback. So you need to then change the configuration of your my.cnf to say you'd like to have something like ws retry autocommit equals, say, 5, so that it retries the autocommit, say, 5 times before it times out. So your application needs to change its behavior when you deal with synchronous replication. However, by having all nodes being equal, you actually have a very, very highly available cluster, so to speak. Galera requires a minimum of 3 nodes because it makes use of a quorum algorithm. So if one node does go away, it can survive on 2 nodes. But if you only had 2 nodes and you needed a quorum algorithm, 50% does not constitute a majority, naturally. And group replication is based on the same paper that Galera is based on, but it is a different implementation. It's a much newer implementation as well, which is why more people probably use Galera cluster in production than compared to group replication. And then there's DRBD, which is RAID over Ethernet, and it may be popular among some folk here as well, I'm not sure. But DRBD was the great way to make sure you have a passive master sitting at another data center or in the same data center, and it copies the data from a block level across Ethernet. Now it only works with things like InnoDB, and if you're already used to something like a SAN, maybe DRBD makes sense. But today with something like semi-synchronous replication, your architectures that you start off with today probably don't need to make use of DRBD. Now, I should talk about the frameworks that are available as well. MMM is a framework that allows you to have multi-master replication. It's been around for over 10 years now, possibly. But when MHA came out, the website for MMM says, do not use it. So you should listen to what the website tells you. There's cluster control, which is not necessarily open source, but you can get started with a 4-node cluster fairly quickly in typically less than 5 minutes. It handles replication of all forms that I talked about earlier, as well as Galera. You can configure HA proxy, proxy SQL, and so forth. And it works with like on-prem, EC2, hybrid, etc. There's Orchestrator, very, very nice tool to actually visualize your entire MySQL topology. Does anybody here use Orchestrator? No. Well, hopefully by the end of today, you will try and install it. Because Orchestrator is now a GitHub project as well. It previously was an Outbrain project. And it allows you to visualize your topology. It also allows you to look at long-running queries. It allows you to move your topology around visually or via an API as well. And it obviously also has a JSON API so that you don't have to use a GUI, but end users do like GUIs as well. There's MHA, great tool that allows for automatic master failover. So you can have n-tier masters with many slaves hanging off of it, and this is what people like DNA, and even initially even what Facebook built their tools on for automatic failover. Then there's also Tungsten Replicator, which is open source fully. It also handles failover, but it doesn't only make use of the MySQL binary log. So what it does is it takes the MySQL bin log, converts it to a transaction history log, a THL file. So now it doubles the size of storage, as well as it's much more chattier on the network. But it's a solution that multiple people do end up using as well. But it also will introduce Java, to your deployment, as well as Ruby. So this may be an issue for some people to install Java on a MySQL machine. MySQL utilities, since 5.6 and greater, also provides MHA-like functionality called MySQL failover, as well as replication admin. These are not very talked about very much, but they do exist, and they can be plugged in to work with MySQL Workbench, so you can do stuff either via GUI. They're all written in Python. Well, actually, it's probably worth talking about what they're written in as well. So these are all written in Python. They're possibly also extensible. MHA is written in Perl. It is actually probably the most extensible and probably the most widely deployed one at the moment as well. And yeah. Percona Replication Manager. Nowadays, you find them already standard inside of the pacemaker agents, so we don't really have to do much more for this. And then there's Replication Manager itself, which works with MariaDB global transaction IDs and MySQL global transaction IDs. Now, this is an important distinction because MySQL has one set of global transaction IDs, and MariaDB has another set that's incompatible with MySQL's. What this means is if you want GTID-based failover with MariaDB, your only choice is Replication Manager. But if you want GTID-based failover with MySQL or Percona Server, you can use MHA or Replication Manager. Now, why is this important? It's important because the replication packet and even what is stored on the binary logs actually differ in MariaDB compared to stock MySQL. So even if you try to get a MySQL bin log from MariaDB to read MySQL's MySQL bin log, it will actually not work. And this is a very common problem that people face when they deploy, because you may have pulled MySQL client utilities from one repository, and you may have pulled a server from another repository, and it turns out that this sort of thing just doesn't work. Now, there is a very good case study about how people can grow from solutions, like they start with MySQL failover, then they maybe move to MHA, and so forth. And you know, if you Google Nylas, N-Y-L-A-S, they make this webmail software. They actually wrote a wonderful case study about how they grew with frameworks, basically. So, GitHub, September 2012, was replacing DRBD with Percona Replication Manager and a pacemaker resource agent. They wanted to have more efficient failovers. They didn't want the DRBD's cold start, and no one at that point in time likes a cold buffer pool. So InnoDB fake changes that's available inside of ExtraDB that you get in Percona Server as well as MariaDB Server was the way to do this. It will actually replay statements from the log and then revert them upon commit time, so you actually get a rollback. So this just warms up the buffer pool. And the idea behind this is also known as replication prefetching. So today, with MySQL 5.7, you don't need InnoDB fake changes. You can use intra-schema parallel replication for this purpose to actually warm up your data. Anyhow, they were starting to see poor performance, and then they were getting high load. And because of poor performance and load, they would actually get failing health checks. And these failing health checks would trigger a failover. So what GitHub was going through was a status of failovers triggering failovers. This is not an optimal thing to do. Of course, something that no one could have predicted, Pacemaker itself would segfault for GitHub. And because they didn't only use MySQL, they also used things like Redis. There would be data drift between Redis as well as MySQL at this point in time. And Redis was there to query the dashboard stream of events that you see inside of GitHub. So for GitHub in 2012, automated failover was the root cause of both their downtime events that took GitHub offline for possibly nearly a day. But this was 2012. A lot has changed, and this is a very good report that one could read, because many people think about automated failovers and deploying automated failovers, but they don't think about what happens when they have too many automated failovers, for example. So is fully automated failover a good idea? Because keep in mind that a false alarm will cause short downtimes, and also restart all the write connections. This is not something that people enjoy doing. Repeated failover was something that Pacemaker and PRM never thought about, which is something that MHA did think about. And MHA never allowed a failover to happen if a failover had occurred in the last 8 hours, because MHA keeps logs of when a failover happened. Now, why would this make sense? This could be because you had an overloaded master, or you were having repeated triggered failovers. So the only way for you to get MHA to operate in a way that would not be consistent with what I would recommend would be to set the last failover min equals n, where n could be, say, 60, at which point MHA will then perform a failover if it performed one even more than an hour ago. Now, data loss is a common problem. Now, what happens if you only have data in the binary log and you've lost, say, 2 bits of data? The only workaround here is, of course, to use semi-synchronous replication. Also, only recent versions of MySQL, so that's MySQL 5.6 and MariaDB 5.5 and greater, have group commit in the binary log. So you can finally turn sync bin log equals 1 and InnoDB flush log at transaction commit equals 1. And this can mean that every time you have few transactions, it will actually call an fsync when it's time to write the disk. So the only caveat is you have either killed the MySQL server, and then these transactions didn't get written to disk, which is a bonus, or you have lost power to the machine. Also, again, transactions didn't get written to the disk. Now, split brain is something you totally want to avoid. Power off can take a fairly long time, and power off varies, so MHA suggests that you actually start writing wrappers around this, so either me-tool, telnet, or if you use the cloud, there are various ways to shut it down as well. However, a lot has changed, and now, as I said earlier, with semi-synchronous replication and an automated failover framework, you really can have a 30-second SLA, and this can be deployed in production with no rhyme or worry. We have proxies in the MySQL world. We have so many proxies. We have MaxScale. Proxies are there to assist with sharding, and the idea behind MaxScale is that it would be a pluggable router. You can use it for logging. You can use it to write to other database backends. You could prevent SQL injections because it has a parser, and then you can write regular expressions to match based on what it gets in the SQL parser. You can route hints and so forth. Now, MaxScale, most popular use case is to load balance Galera clusters. MaxScale, before version 1.4, is great for you to use because it is GPL v2 licensed. You can do whatever you want with it. But MaxScale post version 2.0 has this new license called the business source license, which suggests that if you are trying to use it for any purpose, for more than 3 servers, you actually have to pay a license fee for this. So while you can look at the source code, get it straight from GitHub, you'll actually have to read the license file to know that this is not GPL software. This is naturally not my recommendation going forward. There's also MySQL router that works alongside Fabric, which is something that Oracle MySQL has been developing. It's fully GPL v2 as well. And it's a framework to manage your farms, high availability farms, and also will have built-in sharding capabilities. Some MySQL connectors also have load balancing built in, like the Java connector, the PHP connector, and so forth. And then there's Proxy SQL, where you can use it alongside Galera clusters, just like MaxScale, or you could use it in front of your application tier and multiple replicas behind of it as well. Now, it supports persistent connections, query caching. So the query caching is very important. It actually means that it outperforms MaxScale, and which only MaxScale fixes in 2.1. And again, we see Nihilus as a typical user of this proxy. It is also included with Percona XDB cluster 5.7. So if you download Percona XDB cluster 5.7 and you choose to use Galera cluster naturally, it'll also come with the Proxy SQL admin tool, and the out-of-the-box experience is meant to be so much nicer for you than you having to pull down multiple packages and work stuff yourself. Now, I'm going to talk to you a little bit about sharding. This is one of my favorite fruits that you get in Malaysia. It's the king of fruits, and it also looks kind of sharded. Now, you may not like the fruit, though I suggest you try it if you get the chance to. It is a durian. So the idea behind sharding is that not all data lives in one place. You hash records to partitions, and you can either partition things either alphabetically or you put n users per shard. Typically, people put n users per shard. And then when a user grows out of that shard, then you have to rebalance the shard. So sharding is actually easy. It is the rebalancing of the shards and reallocating resources in case a shard goes down that is actually hard. The resharding of sharding is the hard part. The regularly splitting of shards is the hard part. So how do you do this? There is a storage engine called Spider that will help you with sharding. Spider basically does sharding via SQL. You can have multiple MySQL InnoDB backends, and you can have one node or several nodes that manage all those backends, but treat all the data like it is one. And the reason why you would like to put n users per shard is because you would never like to do a cross-shard join, because that would be notoriously slow, no matter what we do. So even with NDB cluster, where every bit of data is sharded across multiple data nodes, and we have things like the adaptive query language and condition pushdown, you never really want to shard across data nodes. There's also Tungsten Replicator, which, as I said before, handles sharding fairly seamlessly. It makes use of a JMX bean, and it also obviously still makes use of a THL. This is not something that you'd probably want to use so much today. Then there's also JetPants. JetPants is written in Ruby. It is used to power Tumblr, the famous weblogging platform that Yahoo now owns. You can clone replicas. You can rebalance shards. So the rebalancing portion is very important if you ask me. You can do promotions of masters. It handles, obviously, range-based sharding. And it makes use for rebalancing and creating a new shard, makes use of something known as multi-source replication that's available inside of MySQL 5.7 or MariaDB 10.0 and greater. Multi-source replication basically means you have multiple masters writing to a single slave, and this is a great way to provision a new shard. And you can do this in a parallel fashion so that the provisioning is actually fast. Though, one of the cool proxies, sharding frameworks, etc. that is available today is Vitess. Vitess is written by the nice folk at Google who work on the YouTube team. And if you have watched a YouTube video today or this week, you have been served by Vitess. You've been served by Vitess for several years now. And it is meant for you to scale MySQL to serve at YouTube scale, basically. For one, every MySQL connection requires 256 kilobytes of RAM to open up that thread, and it can use up to 3 megabytes of RAM. Vitess doesn't open up, it opens up one thread per connection, but it makes use of BSON, and it has its own BSON connection protocol that means every connection that you open is predictable because it is just 32 kilobytes in size. So that's all the RAM it's going to use. So now you have a predictable workload. Fairly important when you're doing capacity planning. Connection pooling is handled in Go. Vitess, of course, rewrites SQL queries. So if you find a clause like select star from rooms with no limit, Vitess will actually stop that query and add a limit clause next to it. So it'll just do select star from rooms, limit 10. You can set this automatically. Vitess rewrites queries for you. So your developer will get the queries back, but will get a very truncated data set. It, of course, does range-based sharding again, and it is backed by etcd or Zookeeper, so that your cluster view is always kept up to date. And it is also a proxy for query routing. Now, if you don't want to set it all up, and I'm sure most of you will probably want to set it up, if you hand over your credit card details on this website, vitess.io, in typically less than 5 minutes, with the help of Kubernetes, you would have launched a production-ready Vitess instance. This is a great way to get started, but I guess at scale, you probably want to run this yourself. The good news is there's great documentation. There is a very active mailing list and a wonderful, yet another Slack channel to join. So, in the past, we've seen many Failwhales. How many of you here use Twitter? Not as many as I thought. Twitter is basically, they started with MySQL, and they're still on MySQL, but they've evolved with things like Gizzard and a whole bunch of other things that are now dead. But the one thing that has survived is Apache Cotton, which is part of Mesos, which allows you to manage your MySQL infrastructure. We've also seen companies like Dig start with MySQL, then migrate to something like Cassandra because they say MySQL can't scale. But then eventually they come back to MySQL after having lost all their users to Reddit. So, and if you look at history, you'll actually see that there was a DBA who would write blog posts about why they were migrating. And if you look carefully, they just didn't do indexes very well. Of course, all of this is now something you have to look at web.archive.org, but sometimes there's no reason to migrate from something that is working well, or if you think it's not working well enough, maybe you just need to knock on the doors of some experts or to bounce the idea off someone in a bar and say, oh, this is what I'm doing wrong. Security is the third part of what I wanted to talk about. Last year, Philippines had a voter data hack. They have email addresses, passport numbers, and so forth in a 330 gigabyte MySQL dump. And 55 million Filipinos out of some 80 million Filipinos have their voter data leaked. Now, having access to email address, passport numbers, etc., if you look at the schema, you realize that you could, in theory, go out there and get a loan in an overseas Filipino worker's name if you had worked with a bank colleague without verifying the signature, because they can also occasionally verify via thumbprint, which happens to be in this dump. This is really sad because you can't change your thumbprint. Pardon? What? Oh. Yes, I guess, with much difficulty, but for 55 million people to start cutting themselves, not a good idea. Ashley Madison, something that maybe is more close to home, much easier data set for you to look at anyway. I mean, 330 gigabytes MySQL dump is huge. But if you look at this is just a compressed dump. It's only 7 gigs. You can get it fairly easily. I took a look at the data. In fact, if you ever wanted to build Ashley Madison, it's fairly easy because it's got everything, including the PHP files. Here, you have things like names, street addresses, email addresses, phone numbers, credit card details, which most likely all don't work anymore. But you have over 33 million accounts here, and it gives you a fairly good understanding of how you'd run a site like this. Now, this website is not good, right? So if you found yourself here, this is just bad. Anyway, Patreon. I mean, this one I personally use as well, because sometimes you want to reward people who write articles or make music, and you actually give them your credit card details and your name. And it turns out that my details were also leaked in this 13.7 gig MySQL dump, which you can also get. So basically, a lot of people who are kind to creators in the open source world would end up having to get new credit cards. Very inconvenient. And of course, the most famous, Panama Papers. This one is a very unmanageable dump because it's 2.6 terabytes in size. They ran WordPress, Drupal, etc. And thankfully, they were not running MySQL. They ran Oracle. They hacked WordPress and Drupal to make it run well, WordPress especially, to run on Oracle. A lot of these people, with the exception of possibly Ashley Madison, actually got in most likely via SQL injections. Now, there are ways to prevent SQL injections nowadays, and all those proxies I talked about earlier can actually do that for you. MaxScale can provide you opportunity to have a proxy in front of all of your MySQL servers. So it'll actually look at the query, and it can block or ignore. It's quite reasonable to use. It's called a DB firewall filter, and it will actually work with both MaxScale 1.4 and before, as well as 2.0. There's the MySQL Enterprise Firewall, which I'm not going to talk much about because you have to pay money for this, but I include this here for completeness. And there's also Proxy SQL, which allows you to prevent SQL injections out of the box, and also do what Vitess does. When it looks at a select query without a where clause, it can tack on a limit clause, for example. So Proxy SQL can be the gatekeeper. Now, in terms of performance numbers, Proxy SQL way outperforms MaxScale, like way outperforms. And you want to have a proxy that does not hold you back. Your proxy should be not much worse than having direct connections to the database here. And MySQL since 5.7 also has a pre-parse option, which allows you to actually look at queries from the server side. If you didn't want to run a proxy, you could actually write pre-parse scripts if need be. Now, encryption is also quite an important thing to do. Many people think about encryption from multiple standpoints. People always ask for, when MySQL never had encryption, people said, oh, we just need some kind of encryption. When MySQL finally gets some kind of encryption, they say, actually, we want column-level encryption, which we think at the moment is better to actually keep inside of your application. Then people think about system-level encryption, where direct access via SQL is no longer possible. This is not necessarily a good thing. Then some people try column-level encryption via middleware, things like CryptDB or MyDiamo. But they're flaky, and they only work with certain versions of MySQL. They have to be recompiled when new releases come out and so forth. And then some people think, why don't we just run dmcrypt and have full file system encryption as well? But there is CPU overhead on this. Every time you retrieve a page from the buffer pool, it has to decrypt. Same with logs. This actually affects performance way more than having native encryption. So the idea behind encryption inside of MySQL is to make drive-by data exfiltration impossible. So you not only have to steal the data, you also have to access the internal key management system. And this key management system can, of course, give you key rotation as well as scrubbing. So MariaDB Server was actually the first to come out with table or table space encryption. Not because the engineers at MariaDB wanted to make this happen, but because Google, who used MariaDB 10.0 for some of their databases internally, created this so that you never have a problem where Edward Snowden said that the NSA was spying on Google data. They wanted to make sure that everything was encrypted. So this was in reaction to that. And then they open sourced the code, which MariaDB could then port to 10.1. And the design goal was to encrypt all user data that would touch the disk. Not only data inside your InDB table space, but also your logs. This is quite important. You could get set up fairly quickly by having key management on the file system, but of course, if someone broke in, they'd walk away with your keys. So not the wisest thing to do. And of course, you won't get key rotation. So you need an external key management solution. There tend not to be many open source external key management solutions, with the exception of Vault at the moment, that one could actually use in production. And the other one that's not open source, but fairly cheap because you pay by request, is Amazon Key Management Service as well. Amazon KMS can actually give you like 1,000 keys for like $1 or something. So there is a plugin available for Amazon KMS inside a MariaDB server. Of course, there are some caveats. For one, MySQL binlog cannot read encrypted binary logs. So if you have a problem with replication, you are now out of luck at fixing that problem, because MySQL binlog can't decrypt it. If you're going to use Galera, the inbuilt Galera cluster, the Gcache is not encrypted, so you could leak data via the Gcache. Also, backups. Percona Extra Backup supports the backups that are encrypted via MySQL's encryption, not MariaDB's encryption, which is different. So Until very recently, MariaDB forked Percona Extra Backup just about a week ago and released MariaDB Backup. So there is now another fork of a backup solution that one could use. MySQL 5.7, not to be left out, which was released maybe 2 days later than MariaDB 10.1, encrypts InnoDB table spaces as a whole. You use InnoDB file per table, but the logs are still unencrypted. Now, Percona Server 5.7 has worked to make not only the Percona Server 5.7 follow the MySQL encryption, but also have the MariaDB style encryption, which encrypts the logs, and also provides access not only via Amazon KMS, but also via Vault. But all of this is very much beta-ish work that is still being worked on at this very moment. MySQL 8, which is what is being worked on now, is totally where it's at, because MySQL 8 will have everything MariaDB has and more. So one more thing before I forget is that if you have like one WordPress database, it's fairly easy, and it's okay to say error establishing connection to a database server. But as you grow, you need to basically check loads, and you need to provision for loads. So Parse at Facebook created Flashback. If you have MongoDB, you can get your existing workload and play it back. And there's also Percona Lab query playback that allows query playbacks as well. So all of this will prevent database load failure, basically, so to speak. These are capacity planning things you need to think about. So I always like to learn from others, and I hope I've helped you learn from others. I think today, if you're using MySQL, semi-synchronous replication with a failover solution is the way to go, clearly. And tools like Orchestrator, as well as MRM, are building in automatic failover just like MHA. You want to make good backups, but not only do you want to make them, you want to test them, and you may want to save them elsewhere besides just wherever you've currently saved them. You will definitely need to shard as you grow. Definitely use a proven framework. Don't write your own sharding solution because other people have already done the hard work. It's really easy to write a sharding solution, but extremely hard to write the resharding components of said sharding solution. Get a proxy that's a proxy involved. I highly recommend Proxy SQL. MySQL dump and extra backup work great together. Logical backups with MySQL dump and then everything else for extra backup. If you find restores are slow, MyDumper is a great solution. Security is definitely key. You want to prevent SQL injections. You want to encrypt your data at rest. These are extremely important things to do. In 2016, a website that is one of the only alternative media sources in Malaysia had to send updates via Facebook for 10 days because they had database corruption. They had hardware failure that took away their database. That was in 2016. I mean, you should not be skimping on resources. In 2017, maybe you're more familiar with this one, is GitLab. They just use single primary and single secondary in hot standby mode. And they had other database failures before that as well. But it affected many people, right? Over 5,000 projects, 700 users, and so forth. But they've also given a very good incident report about why accidents do happen, why it was down, because they'd removed the database directory by accident. And I think one of the most important things that they've taken here, why was the backup procedure not tested on a regular basis? Because no one took ownership of backups. If you don't test your backups, it is as good as not having any backups. So don't bother running them if you don't want to test them. And there are many ways to test reloading backups if you don't have extra hardware for this. You could just spin up nodes. At Percona, we want to make sure we make things a little better. We want to make things easier. So we build on top of the shoulders of giants like Prometheus, Grafana, and so forth. And we have PMM, which you can deploy via Docker fairly easily if need be, or by yourself. And Percona monitoring and management will help you not only monitor from query analytics, metrics, and so forth, also help you manage via Orchestrator. And the bonus is we have set up demos available for you that you can actually play with existing servers on the internet as well. So integrating with Orchestrator, and this works fully out of the box from MySQL in a GUI. And the next thing, once Orchestrator has automatic failover, will mean that you have a fully out of the box solution to manage many of these failures. Now, in terms of backups, we don't have a GUI for cloud backup, but there have been others like BinLogic that have come up with GUIs for cloud backup. So I think most of you here like the command line like me, but many other people who come from other databases may think that a GUI is the only way forward. So it is clear that we are also getting there. And despite the fact that MySQL is now about 22 years old, we're only now realizing GUIs are fairly important. So with that, I'd like to say thank you for listening, and I'm open to actually have any questions. And the slides will be online.
Exactly. Slides will be online. I guess there aren't any questions right now. Well, I guess you can ask Colin any question at the evening event.
Okay, just one.
Not really a question, but a hint. Just yesterday, one of the huge German telco providers had a database downage and had lots of troubles with their customer and mobile network. Maybe we'll see another story from them the next few days.
So these larger companies tend not to like to give incident reports, right?
Yeah, well, true that.
Yeah, and it could very well be. I think even my friends in Belgium were complaining. Was it on Monday? I think Proximus went down for maybe at least half an hour, and a lot of suspicion on this new Windows malware, virus, whatever. I don't know. I don't use Windows. No. WannaCry, that's the one. Yeah. So I don't know if it's WannaCry or something else, but we'll see. Yeah. Totally.
Okay, so yeah.
So this is oddly specific, but when you mentioned that one of those proxy solutions had this filter against SQL injections that would scan for select everything, and there was no where clause, I wondered what happens if I come up with a query that has a trivial where clause, like where 1 equals 1.
Yep, so if you have a trivial where clause, you can also make rules that do where 1 equals 1, and you can actually keep on adding rules to this depending on the type of developers you have. And a good example of this actually is Airbnb. They wrote also a very nice incident report because Airbnb runs Ruby on Rails, and they use a lot of these Amazon services and so forth. And Ruby would have VM corruption sometimes, where it would do deletes on where 1 equals 1. This is actually not cool. So they needed a proxy that would stop this from happening, because otherwise you'd lose transaction data for that node, which could affect Airbnb. And we talked about this offline earlier. If you arrive at a place and you don't have a room, this could be a problem. This is probably a bigger problem with something like home rentals.
So that thing is not supposed to stop external attackers that use some SQL injection vector into your application, but more like guard against application
so by default, both DB firewall filter in MySQL as well as proxy SQL have rules for SQL injections. All the SQL injections are there by default. But in addition, you can add rules to it as well that can stop developers that are lazy or crashing bugs in a VM, where these things they do happen. So you can totally extend the rule set, but the default rule set is there for SQL injection prevention. Question at the back.
Holy, where were you guys in the morning?
Yeah. Yes, it is. Well, with regards to SQL injections, I think nowadays we realize what kind of queries are bad. But it is heuristics, yes, absolutely.
But in theory, you could stop a query, you could block a query that's a legitimate thing that had data like body tables actually wants to go to school.
Absolutely. I mean, this if you add the rule like to limit based on nothing, then you actually did stop a legitimate query. But this is you're stopping the fact that hey, I don't want my database to be going for a full table scan. So that actually is legitimate. But that's something that you as the database administrator will tell everybody. It's like a company-wide policy, right? Basically, like, look, if you deploy without a where clause, we're just going to limit your query result set. But that's not turned on by default. That's something you put on there if you want. But it's typical in large environments to actually do this, because if you have 10,000 developers, they have bad days too. They're all probably very good developers, but they have bad days. We'll just leave it at that. Yeah.
Okay, so thanks again, Colin, for answering all these questions.